Alright, in this video we're going to be talking about the inverse tangent function and just doing some example problems where we evaluate the inverse tangent function. Alright, so the first thing, just like with the other inverse trig functions, we only use part of the unit circle when we're doing the inverse tangent function. And if you haven't seen the video that I did where I explained the definition of the inverse tangent function and what it all means and kind of where it comes from, I would definitely advise watching that video before you watch this one. Because in that video we talked about that for the inverse tangent function, we only use the right half of the unit circle. Right? We only use values between negative pi over 2 and positive pi over 2. Right? And in that other video I explained why we do that. So check that out if you don't remember why that is. And so for the tangent inverse function, if I'm going to evaluate it, if I'm given tangent inverse of 1, basically what that means is that the tangent of some number is going to equal 1. Right? And that number that I'm looking for is one of these pi numbers, pi over 6, pi over 4, pi over 3, pi over 2, one of those pi numbers from the unit circle. Right? So I have to figure out, well, what number, when I do the tangent of it, does it give me 1? Well, to do that, we need to remember the definition of the tangent function. Remember, when we're dealing with the unit circle, the tangent function is defined as the y-coordinate over the x-coordinate. Right? Tangent is the y over the x. So when I'm doing the inverse tangent function, I have to look at my unit circle, I have to look at my terminal points, my x and y coordinates, and I have to figure out for which one of those on that right half of the unit circle, when I put y over x, does it equal 1? Alright, well, to equal 1, that's not that hard to figure out, because if I put one thing over itself, that's the only way that I'm going to get 1 out of a fraction, if I have the same thing in the numerator and denominator. So which point on the unit circle is going to give me the same number for both the x and the y, and if you remember your trig hand, if you put down the middle finger, which corresponds to the pi over 4, you get root 2 over 2 for the x and root 2 over 2 for the y. Right, so my terminal point for pi over 4 is root 2 over 2, comma, root 2 over 2. And when I do the y over the x, right, I have root 2 over 2 over root 2 over 2, and the halves cancel out, the root 2's cancel out, and that is just going to equal 1. And so tangent inverse of 1 is equal to pi over 4. Right, because tangent of pi over 4, right, when I go to pi over 4 and I do the y-coordinate over the x-coordinate, that gives me 1. Right, so when you're evaluating inverse tangent, it's like when you're evaluating the tangent function, but you're doing it backwards. You're given that the answer equals 1, and you have to find the pi number that when I do the definition of tangent, y over x, which one of those y over x's is going to give me the value of 1. Right, so that's how we evaluate the inverse tangent function. Right, so tangent inverse of 1 equals pi over 4, because tangent of pi over 4 equals 1, as we saw here when we do the y over x, we get 1. Alright, next one. Tangent inverse of negative square root of 3. Alright, well, when I have this negative number in here, I know right away that it's not going to be one of those numbers from the first quadrant, right? Because in the first quadrant, all my x and y coordinates are positive. So if I do y over x for the numbers in the first quadrant, it's always going to come out to a positive result. If I'm doing tangent inverse of a negative number, that's going to have to be one of these points down here in the fourth quadrant, right? Because in the fourth quadrant, I have a positive x, but a negative y. So when I do y over x, it's a negative over a positive, which is going to give me a negative result. All right, so I know it's got to be one of those numbers from down in the fourth quadrant. Now remember, for the fourth quadrant, when we're doing inverse tangent, just like with inverse sine, we don't think of these as going all the way around the circle and getting like 5 pi over 3 or 7 pi over 4 or 11 pi over 6. We think them as the negatives of the numbers from that first quadrant. All right, so the first one we get to in the fourth quadrant is negative pi over 6. The second one is negative pi over 4, and then negative pi over 3. Right, and the reason we have to think of them that way is if you recall, if you watched that other video I did on the definition of the inverse tangent function, we had to limit the domain of the tangent function in order to make it one-to-one so that it could have an inverse. And the way that we limit the domain is that we take the values of the tangent function in between negative pi over 2 and positive pi over 2. Right? And so when we go to the unit circle, we take just that right half of the unit circle, but we think of the fourth quadrant down here as negative values instead of going around the circle this way to get positive values. All right, so I explained that a little bit on that other video I did. So if what I just said was not enough to explain it, watch that other video where I explain in more detail. All right, so if I want tangent inverse of pi over 3, tangent inverse of negative square root of 3. Right, so same thing I did up here. I have to take the x and y coordinates of my points there in the fourth quadrant, and when I do y over x, which one of those is going to simplify to be negative square root of 3? Well, let me fill in my terminal points, and then I can try to pick which one is going to be the right one. All right, so for pi over 6, remember, using the trig hand, pi over 6 is your ring finger, so my x is root 3 over 2, and my y is 1/2, right? Remember, when you put your finger down, x is the number above, y is the number below. So for pi over 6, it's root 3 over 2, comma 1/2. And then for pi over 3 is your index finger, it's 1/2, and then root 3 over 2. Right, which means to get the ones in the fourth quadrant, I just reflect all those numbers down, and I just make the y coordinates negative, because any point in the fourth quadrant has a positive x coordinate, but a negative y coordinate. So this is going to be, for negative pi over 6, it's going to be root 3 over 2, negative 1/2. For pi over 4, it's going to be root 2 over 2, negative root 2 over 2. And for negative pi over 3, it's going to be 1/2, negative root 3 over 2. All right, so those are my points in my fourth quadrant, and now I have to take y over x, because remember, we're doing inverse tangent, and the definition of tangent is the y coordinate over the x coordinate. So now I think about it, if I do the y over the x, which one of those, when I simplify it, is it going to give me the square root of 3? Well, I only have a couple choices. I know it's not going to be the pi over 4, because when I do negative root 2 over 2 over root 2 over 2, that's going to give me negative 1. Just like for this one here, for the positive pi over 4, it gave me positive 1. Well, for negative pi over 4, the tangent of that is going to be negative 1. So I know it's not that one. It's going to be one of these ones that has the square root of 3. Right? It's either the negative pi over 6, which has root 3 over 2, negative 1/2, or it's going to be the negative pi over 3, which is 1/2, negative root 3 over 2. Right? So you can try each one. You can try to figure it out. If you're not sure, just try it. Just put y over x and simplify it. See if you get negative square root of 3. I think it's going to be this one here. Right, the negative pi over 3, because if I do the y coordinate, negative root 3 over 2, right, I want that negative root 3 on top, and the 1/2 on the bottom, right, the halves cancel out, and then negative root 3 over 1 is negative square root of 3. Right, so the tangent inverse of negative square root of 3 is negative pi over 3. Right, because if I do the tangent of negative pi over 3, and I do y over x, I do this, and I get negative square root of 3. Right, so evaluating the inverse tangent is a little more complicated. Remember, if you watch the videos I did for inverse sine and inverse cosine, for inverse sine, you're just looking for the y coordinates, because the definition of sine is just the y coordinate. Right, for inverse cosine, you're looking for the x coordinates, because the definition of cosine is just the x coordinate. Since the definition of tangent is y over x, you actually have to do the y coordinate over the x coordinate and do the work to simplify it to make sure it gives you the number that you're looking for, in this case that negative square root of 3. Now the good news is there's really only 4 different numbers you can get. Well, more than that, but 3 of them are just the negatives of the other one. So when it's pi over 4, when you do root 2 over 2 over root 2 over 2, that's going to equal 1. Right? For pi over 3, like we saw here, you're going to get square root of 3. If you do the pi over 6 with a negative pi over 6, you're going to have 1 over the square root of 3, which when you rationalize it, you would get 3 root 3 over, you would get 1 over root 3, so you get root 3 over 3. I think that's what, without actually doing the work, I'm pretty sure that's what that one's going to come out to. So if you have, if you have tangent inverse of root 3 over 3, it's going to be pi over 6. If you have just root 3, it's going to be pi over 3. If you have a 1, it's going to be pi over 4. And if any of those are negative, then it's just the negative of the pi over 6, pi over 4, pi over 3. Right? The other possibility is 0. Right? For 0 here, I didn't put that terminal point in, but that's a terminal point of 1, 0. There, if I do y over x, 0 over 1 is going to give me 0. So tangent inverse of 0 is 0. Right? So there's really only 4 different numbers you can use on the unit circle to do tangent inverse. And like I said in that other video that I did, once you do a few of them, you start to just see the same numbers over and over again, and it gets easier and easier the more of them you do. All right, so, and if you're not sure, if you're not to the point yet where you remember seeing these numbers a bunch of times, you just do the y over the x, right? Let me take the y coordinate over the x coordinate, let me simplify it. Does it give me this? If it does, then that pi number is my answer. If it doesn't, well, then let me try another point. Let me try this y over x and simplify that one. If that one doesn't work, let me try this one. And you just keep trying them until you find the one that gives you the number that's in the parentheses there, and then you've got it. All right, so that's our inverse tangent function using the unit circle. Now, what about this one here? Tangent inverse of 20. Well, looking at the numbers I have on the unit circle, if I do the y coordinates over the x coordinates for any of those, would any of those give me a nice number of 20? No, that's not going to work out. You can try if you want to. You can take each one of these points from that right half of the unit circle and do y over x. But when you simplify those, none of them are going to come out to 20. Right? So if you get one of the numbers, or if you're trying to do the tangent inverse of a number that we don't have from the unit circle, and remember, the ones on the unit circle are going to be either positive or negative 1, positive negative square root of 3, positive negative square root of 3 over 3, or 0. If it's any number besides that, then you're going to have to use your calculator to evaluate the inverse tangent function. All right, so to do tangent inverse of 20, and again, I showed you this when I did the ones on inverse sine and inverse cosine, but on my calculator, the tangent button is right about there, and above that, if you can see in blue, it says tangent inverse, right? It has that tangent to the negative 1. So to do tangent inverse, I do second and then tangent. All right, so that gives me the tangent inverse, and then I type in my number, my input value, which is 20. All right, so I'm doing tangent inverse of 20, and I get 1.52 something. All right, 1.5208, let's say. All right, so that's my approximate value of tangent inverse of 20. All right, now you can do the same thing for all these other ones. Like I can do in my calculator tangent inverse of 1. Right? So I can do tangent inverse of 1 and hit enter, but my calculator doesn't tell me that that's pi over 4. My calculator gives me the decimal value for pi over 4, which is 0.785398. And then, if you have to give the exact answer, if you can figure out that 0.785398 is pi divided by 4, then you can kind of piece it together and figure out that that's pi over 4. But if you can't, then you're stuck with a decimal when you need that pi number, which is why we use the unit circle when we can to get the exact values. We only use a calculator if the number we're looking for is not one of those ones that we can find on the unit circle. All right. And just one other side note, when you're using your calculator in this context to do the inverse tangent, your calculator has to be in radian mode. All right, so the mode button on my calculator, which is next to the second key, the third one down says radian and degree. So if you did tangent inverse of 20 and got a different answer, it's probably because your calculator is in degree mode rather than radian mode. So if you switch it to radian mode, you should get the same answer that I got here. Right now, for some trigonometric problems, your calculator will need to be in degree mode. Right? Trigonometry is also used for measuring angles that are measured in degrees. So for some trig problems, we will have to be in degree mode on the calculator. When that comes up, I'll make sure I point out to you, here we have to be in radian mode, here we have to be in degree mode. It's important to be able to know when to switch between those two and to know how to do it. All right, so that's inverse tangent. Again, you're looking at the right half of the unit circle. You're looking for the y over the x to equal the number that you're given in the parentheses, and that's how you do it.